This video explains KNN, that's also called as K nearest neighbor. K nearest neighbor is a technique that is used to classify or categorize a query by comparing it against some already existing data. The data that already exists is called as training or reference set, and the data that we are going to for which we have to make a decision is called as query. So query is compared against already existing reference set to categorize it. K is a number that can vary from 1 to n. If, for example, K is set as 1, then the classification of new observation is said to be equal to the class of the single most similar observation. So in this case, we'll be looking for one observation that's closest to the query. If K is set to 3, then we will see that our query, it relates to or it matches with which 3 most related points. And these related points, they are measured based on Euclidean distance. That's distance between two points on a line. Some examples of the application of KNN are using average balance and age of a person to determine their tendency to default. Now, for example, if a bank or any financial institution, they want to assess if a person would default or not, so they would collect his or her data, that will called as query, and then they will compare it against already existing data, and then they will see that the credentials or the value of query matches with the closest one. So for example, if a statistician sets the value K is equal to 3, so they will see that this value, it matches with which 3 most closest point. And if those 3 closest point, they are about default, then a manager would make a decision that this person is most likely to default. On the other hand, if those 3 points against which query is being compared, they are about not defaulting, then the decision would be exactly the opposite. Or another case could be that where someone has to make a decision about credit card. So someone applies for a credit card, and let's say we have two criteria to make a decision about approval or rejecting the application for credit card, and one is oldest account, which means how old is the account, and second thing is that number of hard queries. Now a manager would collect data about application, that will be called as query. So they will see that the person who is applying, his account is how years old and how many hard queries he has on their account, and then they will compare it against existing data, and then a decision would be made accordingly. This example is about credit card application. So for example, this is hypothetical data in which we have data about oldest account, which means how old is the account of people, and then how many hard queries they have, and then what was the result. Was their credit card application approved or rejected? So this is a reference set that will provide the basis of comparison. And then there is a new application, and the new application in which oldest account is 5 years old and there are 2 hard queries, and you have to make a decision that whether it should be approved or rejected. And what we will do is that we will see that these credentials, these values, they match with, let's say for example, if we say that we want to make a decision based on 2 nearest values. So what are the 2 closest values that match with these credentials, and what was the decision in that case? If in that case it was rejected, so this application would be rejected. But on the other hand, if those 2 nearest application, they were approved, then this one will also be approved. The first step towards making a decision is to make a scatter plot that will give a visual idea of the distribution. I select this data and then press Ctrl Q and that will give us some options. So one option is charts, and in scatter plot, and here is scatter plot. Now we need to refine it a little bit. So for instance, let's say this is the title will be credit card application, and then I will click on this plus button and access titles, and now in order to see which axis here is oldest account and which axis is hard queries, I will right click and I will go to select data, and in select data, if I click on this one, edit, that's existing series, it shows that X values are 9, 6, 7, 4 and 10, and that is this one. So this is our X-axis, oldest account is X-axis, and series Y values are 33052, so that is 33052, so that's our Y-axis. Okay, and we can accordingly label it. After that, I would label these data points, and for that right click on them and add data labels and click on this one, and it shows these values, but these are not the values that we want. We want labels in terms of like these decision approved or rejected, which mean these data points, what happened to them, were they approved or rejected. So we need to change this one a little bit. Again, I click on format data labels, and then I would say value from cells, and from this cell, that's results, and I will click OK. Okay, so these decision label appear, but it's still showing these values numbers. So I will click on this one, Y value, and show leader lines. Now it's only showing us decision. For the axis title, we already have this one. So we had already clicked on access titles, and it's showing us oldest account and hard queries. Now the next thing is that these points, they refer to this table, and now I want to add here the values from our query, that's 5 and 2, and for that click on select a data so that we can also add it there. And in select data, I will add a new series, and in that new series, we know where X value will be 5 and Y value will be 2. So this is our new value, our query value, it appears here. And as you can see here, that this is 5 and 2, oldest account 5. So on this axis, oldest account it's 5, 4 and 5 here, and along hard query, that's y axis is 2, so it's 2. So this is 5 and 2, its dimensions are 5, 2. Now in the next step, what we have to do is that we have to see that those points that are closest to this point, what happened to them? Were they approved or were they rejected? And so for example, I can see that this is the closest point, this one that was rejected. Similarly, this one that was also rejected, and this one that was approved, and this one also was approved. So I can see the if I compare my query with 4 closest observation, I can see 2 of them were rejected and 2 of them were approved. And similarly, if I increase a distance, if I go to this one, then that was rejected, and maybe then similarly this one, that's the next one. So this is how KNN works. Our query would be compared with closest data points, and we'll see what happened to them. In the next step, we will measure Euclidean distance. That's the distance of this point against this point, and distance of this point against this point. So the formula for Euclidean distance is, we'll take square root and this one log it, because it's supposed to remain same, minus this value and its square, plus this value, and again log it because it's supposed to remain same, minus 3, and then again the square of this one, and this Euclidean distance turns out to be 4.12. This Euclidean distance shows the distance of our query point from these data points. So for example, this is 4.123, and our data points here are 9 and 3. Oldest count is 9 and hard query is 3. So here is oldest count, that's 9, and this is 3. So which means the first one is this one. And 4.12 is the distance of our query point from this one. So the distance between them is 4.123, the linear distance. In the next step, we will rank these values in order to see which one is the highest one and which one is the lowest one, and for that we will use a rank function. And for that we use this rank argument. We select this one, data rank this one, comma, with respect to this range, and then freeze it by pressing F4, and the last argument is that one, that's ascending order. So our argument is here is that we want to rank D3 with respect to this whole range, and we want this ranking to be in ascending order, and it gives this ranking. Now I would pause here to discuss a few things about this ranking function. In our ranking command, I used 1, which means that's ascending order. And if I, instead of one argument, if I use 0, then that will rank this one by descending order. In ascending order, the highest value, so for example, this is our highest value 25, our highest value is 7.22, that's also appears as at the highest rank, and our lowest value 1, that appears at the lowest rank. So values are ranked in an ascending order, which also means that the smallest value is ranked as number 1, and the highest value is given the highest rank. In descending order, it will be exactly the opposite. So for instance, if in this ranking function I use argument 0 instead of 1, then this value will be changed to 25, and the highest value, this one, it will be changed to 1, and all other values, they will be changed accordingly. So that's the main difference between ascending and descending order. Excel also has a default function whereby if you don't add 1 or 0, then it will rank them by descending order. That's one thing. The second thing is that the default ranking function of Excel, it might have some duplicate values, and some ranking might be skipped. So for instance, here you can see for instance that 2 appears multiple times, so this is 2, and then similarly 11 also appears multiple times, and accordingly this ranking, it may not be continuous. Some numbers might be skipping. Let us see which numbers are missing in this ranking. I paste this as special values and then sort and filter smallest value to largest, and it shows that 1 2 3 is missing, 4 5 6 appears multiple time, and therefore 7 and 8 are missing, 9 appears 2 time, and then 11 appears 4 times, which mean 12 13 and 14 are missing, and then 15 appears 2 time, and so which means 16 is missing here. Then 17 appears 2 time, which means 18 will be missing here, and then 19 20. So that is the default function, a ranking function in Excel, which means it will skip some numbers. Now the next step is to make a decision that you want to compare your query against how many closest points. So for instance, let's say I want to compare it with the 2 nearest point or 2 nearest neighbor, and of course I can expect that my answer will be reject, because these 2 nearest neighbor are this one, that's a reject, and this is also reject if it is taken by Excel, or this one, if it is taken this one, then it will be approved. So if Excel chooses these 2 points as nearest neighbor, then the answer would be rejected. However, if Excel chooses these 2 points as the nearest one, then answer will be 50-50, which means one was rejected and other was approved. We will use VLOOKUP function to search these numbers in our ranking and then to pull out value about decision, whether approved or rejected. And to use VLOOKUP function, we need to organize data in a specific format. To use VLOOKUP function, I have organized data here, and here I have chosen only 2 columns, that's rank and results. I have trimmed unnecessary columns, especially the oldest count and hard queries, because I did not want VLOOKUP function to compare these values 1 and 2 with the values in oldest count, because that's irrelevant in our case. We just want to compare or match these values with the rank column and not anyone else. So therefore I'm using only this rank column, and the column from which values need to be pulled out, or the decision categorical variable is to be pulled out, it should come later. So first is the column with against whom these values, these k values, they need to be matched, and then the column from which values need to be pulled out, it should follow. And over here we can say our decision, and we will use VLOOKUP function, that is VLOOKUP, and in VLOOKUP we want this value of k3, and we want to see in this table, and I will lock it F4, and I want to pull out the results from the second column, that's the results column. That's how VLOOKUP function works. So I will mention here too that pull out values from second column, and the last one is I will mention here false, which means that I want exact matches. So when I click it, when I enter it, it gives rejected, which means the decision is that rejected. And if I move to the next one, it says approved. So that's pretty much the same thing that we were expecting earlier in this diagram, which means if your criteria is that you want to compare your query with the closest one neighbor, then your decision would be to reject that credit card application. And on the other hand, if you want to compare this query point with 2 closest neighbor, then you have a tie, which means that was approved. We can also go further, but as you know that some values are missing. So for example, as we saw earlier that I think number 3 would be missing and number 5 would also be missing, but we can do that. We can just like so for example, if I pull it, it will show not applicable because this 3 is missing here. Okay, so in this type of situations, your final decision, it will be determined by your criteria, that your criteria was to compare with one closest neighbor or two closest neighbor. If it was one closest neighbor, your decision is rejected. If your decision was two closest neighbor, then it's a tie, and then in that case manager can use his discretion to make a decision.